Hi there, geometry students. This is your video for section 3.3. We're continuing in the chapter on parallel and perpendicular lines. I just want to apologize if I sound congested. I do have a bit of a stuffy nose, so I'll try to speak as clearly and as loud as possible. But make sure you have this goal written down in your goal sheet. The goal here is to determine whether two lines are parallel. So far we've talked about what parallel lines are. We've talked about some theorems that we can talk about what angles would be congruent or supplementary if we have parallel lines. Now we're going to kind of go backwards and determine or see what we can use to determine if lines are parallel. So our essential understanding here says you can use certain angle pairs to determine or to decide whether two lines are parallel. All right. And hopefully you can see that I have a pair of Converse shoe here. So we're going to be using the converse of some of our theorems. So that's what we're going to do. We're going to look at theorems that we had from section 1 or section 2. We're in section 3 now, but section 2 theorems are all right here. We had the alternate interior angles theorem, the corresponding angles theorem, the alternate exterior, and the same side interior angle postulate. And what I want you to do is think about how you could write the converse. Now, if you think back to the last chapter, the converse is just written backwards. So instead of if P, then Q, we're doing if Q, then P. And sometimes you have to reword it a little bit. But the converse of the alternate interior angles theorem would say that if, and I might have to type these because it's going to take me a little bit to write them out, so I'm just going to type them. But I believe I would say if, we'll just say if two lines in a transversal create congruent alternate interior angles, or alternate interior angles that are congruent, then the two lines are parallel. So we're starting off with if the two lines are parallel, then the alternate interior angles are congruent. Now we're saying if the alternate interior angles are congruent, then the two lines are parallel. So we're just reversing it. We're doing the converse. And you're going to find that this is actually true. This is one of our theorems that we're going to talk about today. So the converse of these theorems are true theorems. The second one, corresponding angles theorem. So remember the converse would be backwards. So it says if a transversal intersects two parallel lines, then the corresponding angles are congruent. Well, I'm going to kind of piggyback off of this one right here. So if two lines in a transversal create, instead of alternate interior angles, we're going to say corresponding angles that are congruent, then the two lines are parallel. So if we have congruent corresponding angles, then we know the two lines are parallel. So there's our second way to prove if two lines are parallel. So for a third one, this is the converse of the alternate exterior angles theorem. So the alternate exterior angles theorem says if a transversal intersects two parallel lines, again, then the alternate exterior angles are congruent. Well, if we do this backwards again, we can say that if two lines in a transversal create alternate exterior angles that are congruent, then the two lines are parallel. All right, that's the third way to prove if lines are parallel or not. And here's the fourth one. This is the same side interior angles postulate is a postulate. And that deals with supplementary. So I'm going to actually change this a bit. But it says if a transversal intersects two parallel lines, then the same side interior angles are supplementary. Well, we can say that if two lines in a transversal create supplementary same side interior angles, then the two lines are also parallel. That's the fourth way we have. The converse would also be true. This is the fourth way we have that would show whether parallel lines are, or lines are parallel or not. So the way it looks in your notes, or actually these are all written out for you. So the converse is written out. So in our example there, the converse of the corresponding angles theorem, if angles 2 and 3 are congruent, then, well, then line L is parallel to line M. Those are our two lines in question. The converse of the alternate interior angle theorem, if we have that angle 4 and 6, which are alternate interior, if those are congruent, then line L and M are also parallel. Third one, converse of the same side interior angles postulate, so I guess I switched these two around. If measure of angle 3 plus the measure of angle 6 is going to get you to 180, so they're supplementary, then line M and line L are parallel. And the last one, dealing with alternate exterior angles, which I think was the third one on the last page. If angles 1 and 7, which are alternate and exterior angles, if those are congruent, then line L, you can probably guess it, is parallel to line M. Okay, so we're going to look for situations where we can prove if lines are either, or if we have any of these alternate exterior that are congruent, alternate interior that are congruent, same side interior that are supplementary, or corresponding angles that are congruent. Those are ways we can use to prove parallel lines. So I got a couple examples here. So the first one, we want to know which lines or segments are parallel. Even if they look parallel, if they're not labeled, we can't assume that they're parallel until we use one of these new theorems that we have. So let's look at example 1. We have lines TR, Q, and S. We have two angles. We'll say angle 1 and angle 2 here. Looks like those would be alternate exterior angles if we were dealing with these two lines, the line Q and S, and the transversal right here. If we know that those are two are congruent, that's the only ones we're given that are congruent. Just by their the little arcs that are there, so that means they're congruent. Then the two lines in question are Q and S, and those two would be congruent, or sorry, parallel. That's all we have from there. We prove that those are parallel using my justification would be alternate exterior angles, so that would be theorem 3.7, the converse of the alternate exterior angles theorem. I'm just going to say theorem 3.7 for right now, instead of having to write it all out. Now, number 2, you might be thinking, well, I know that line or segment JM is parallel to segment QN, which they are. They're labeled that way. We also have that segment JQ is parallel to segment MN because they're labeled that way. But are there any other parallel lines? We want to see if we can find any angles that would be congruent anywhere. So the ones that are labeled, there's none that are congruent. How about from our diagram? So if we have that, oh, well, if we have that if these are parallel right here, then we know that if, well, then we know that same side interior angles, so we could say that these are supplementary, so this would have to be 112 degrees, because they're supplementary, 68 and 112. Okay. We could also say this would be same side interior then, so this would have to be supplementary to 112, so this is 68 degrees. And then this is same side interior up here, so this would be 112 as well. And then if we know that, now we have corresponding angles here that are congruent, 112 and 112. So now we know that this line is also parallel. So we can say that KP is also parallel to JQ. It is also parallel to MN. And I use both the same side interior angles theorem, the converse, and the corresponding angles, converse to the corresponding angles theorem. So that'd be theorem 3.4 and 3.6. So say theorems, 3.4 and 3.6. Okay, two more examples. Find the value of x for which line A would be parallel to line B. So if A is parallel to B, line A is parallel to line A, B, we have 65 degrees here, and this one right here would be x plus 72. Think about that. Those are same side interior angles, so that means that they would have to be supplementary, not congruent. That's the one where it's supplementary. So the 65 plus the x plus 72 must add up to 180 degrees. So that would be x plus 137 equals 80 degrees. And if I solve for x, oops, sorry, 180, 137, x will get me to 43 degrees, or 43 would be the value of x. All right. Now number two, we've got a bit of a complicated looking picture here, but let's see. What do we know about, we are assuming that A and B are parallel, and if this is our transversal right here, or a transversal, and we're looking at this angle right here, this angle would be congruent to this angle. Those are opposite, alternate interior. So that would mean that 12x and the 3x would be supplementary, because this is a linear pair here. So we'll say that 12x plus 3x equals 180. 15x equals 180. So x is equal to whatever 180 divided by 15 is. And that's going to be 12? I think it's 12. I'm just going to go and say it's 12. I'm not going to check that, but I'm pretty sure it's 12. And I'm not sure about the 6x. We wouldn't necessarily need to prove anything there. So we'll just leave it at that. X is equal to 12 because of we know those would be supplementary, those two angles. All right, last thing I want to do here, and we'll do one of these in class next time, but I think I want to go through one of these proofs real quick. This first proof says, it gives you a diagram to the right. It also gives you that, this is going to be our first step, always a given, that angle 16 is congruent to angle 8, and that P and Q are parallel. P and Q are parallel to each other. We want to try and prove that line L and line M are parallel. So my guess is we're going to have to use one of those theorems at the end to show that they're parallel. So one of those new theorems is converses. So let's see, step 2. Anything else from the given? Well, if these are parallel, let's just look at the diagram then. We have that 16 is congruent to 8. Okay, we want to get to proving that line L and M are congruent. But if segments P and Q are not congruent, sorry, we're going with parallel. If lines P and Q are parallel, we can say that angle 1, if find angle 16 is congruent to angle 1, that would be same side, or corresponding angles. It's a corresponding angles theorem. Sorry, that's my angle symbol. Corresponding angles theorem. And then, well, then we can say that angle 1 is congruent to angle 8. Well, we should really say one step in here that angle 8 is congruent to angle 16. Angle 16. I know we said that angle 16 is congruent to angle 8, but if we truly want to say that would be the symmetric property of congruence. If we really want to say then that angle 1 is congruent to angle 8, we'd have to use the transitive property, since we don't have substitution for congruence. We'd use the transitive property. I don't know why that happened, but the transitive property of congruence, because if we have angle 8 is congruent to angle 16 is congruent to angle 1, then we conclude that angle 8 is congruent to angle 1. So really, this should be flipped as well. All right. Now, if angle 8 is congruent to angle 1, those are corresponding angles as well. And if we're dealing with Q as your transversal through lines L and M, then we can already say that line L is parallel to line M because of the converse of the corresponding angles theorem. And I think that one is the converse of, that one's Theorem 3.4. The converse of the corresponding angles theorem is Theorem 3.4. That says if corresponding angles are congruent, so 1 and 8 are congruent, we just showed that, then the two lines L and M are parallel. Yay, we proved it in 4 steps. So these are pretty solid proofs. You only need 4 steps, well, really 5 if you add this one right here in there. Okay, but that's all that we're going to do here for section 3.3. Please make sure you have quality notes, and don't forget to self-assess yourself afterwards. We will do some practice with this in class. So until next time, we'll see you.